So we'll continue with a technical track. So our next speaker is both a great technologist that I had a chance to chat with yesterday, as well as a very accomplished entrepreneur. So Dr. Micha Breakstone is a Tel Aviv-based entrepreneur who had two prior success stories. So he helped build Sumly that was acquired by Yahoo, and he founded Ginger's business unit that was acquired by Intel. But what he's doing now, I think, is even more exciting. So he is currently building the startup Chorus.ai, which is the leading conversational platform that you can use to build any kind of conversational tools that you want to have, no matter for chatbots or for other things. And I think that is a really, really exciting topic as AI and all of these platforms for conversational commerce and so on have been very hot. So please welcome Dr. Micha Breakstone on stage. Breakstone, sorry. And thank you very much for coming all the way from Israel to us. It's a great honor to have you here.
Thank you so much. And, thank you for hosting us in this lovely city of Cluj. Background music.
You get your intro video as well.
Sorry? Oh, cool. So just waiting for my presentation to come up. Can I have it on the screen here as well? I can start now. So first of all, thank you for hosting in this wonderful city. What I'll be talking about are the advantages of building your AI stack in-house. So Yossi early on this morning asked how many developers are here and how many startup people are here. So I'm not sure how relevant this is by the show of hands, but hopefully it will be interesting to you guys. So let's see. Yeah, so the talk I'll go through, the outline is I'll talk a bit about the background of AI as a strategy, deciding on artificial intelligence as a strategy, 5 reasons to decide to build your AI in-house, and I'll walk through a real-life example, namely at Chorus, why we chose to build our own AI and what advantages we found. So in terms of background, as you all know, using AI has become extremely popular. Just looking at statistics, there's been a 14 times increase in the number of active AI startups since 2000. There's been a 14 increase in the number of active, a 6-time increase in funding from VCs, and the jobs, if you look at the jobs in AI, so just from 2013, there's been a 4.5 increase. And all the top companies in the world are investing in AI. Google's CEO went so far as to say that Google is an AI-first company. All top 5 tech companies in the world have their own virtual personal assistants. And they're even going so far as to build their own hardware to support AI. So the question is, obviously there are many advantages of building AI, but the question is, it's so much focus and so much cost, and you have, a lot of AI has been commoditized. You can use speech through Google Speech, or you can use various different computer vision APIs. So the question begs itself, when you start a startup, do you actually want to build your own AI or not? And this is what I will be covering now. So I think the first reason to consider building your own AI is precision. So when you go with an external API, it's either not customizable at all, or very hard to customize, or not very much customizable. And when you're creating a novel application, it's very important, obviously, that you are better than than anything out there for your use case. So, as an example, if you were building a virtual personal assistant, think of a Siri for children. You'd want to tune the acoustic model in a way that is able to pick up pitches that are much higher than standard. So you'd want to be able to tune your own acoustic model, build your own speech engine, basically. If you're building a tool to monitor movement of employees in a factory, you have this additional data that you know what the database of faces looks like. So why settle for general precision when you can use the data that you have at hand to increase precision? So that's the first reason to consider building your own AI, precision. The second is cost. So if you're doing a one-off thing, or if you need to process a few things, it's not a problem. I think Google API for voice is about $1.50 an hour in total. The Amazon recognition video is about $6 an hour, non-real time. But if you're planning on processing thousands and thousands of calls every day, or thousands of hours of video every day, those prices rack up, and there's a huge problem scaling. So any company or any startup that is building itself out to build enterprise-grade, scalable services should consider very deeply building their own AI in-house, just in terms of cost and unit economics. The third one is privacy. We're in Europe. We all know that GDPR has recently been enforced. Using an external API or using an external service, you're immediately sending all of your customers' data, all of your data, to a third party for processing. You have no idea, even if they delete it and purge it, you don't have any idea what metadata they're keeping. So if you want to keep maximal privacy and security, the best is also to build it in-house. And a fourth is a little more elusive one. It's achieving real-time. So yes, some APIs do provide real-time or near real-time services. However, if the service you're building needs to interact truly in a live mode, then you're going to need to take care of latency on the network and services going down. But even more so, when you process, for example, when you process speech, utterances, the endpoints for the utterances determine when or how the engine actually processes something. So if I say a sentence and the sentence is 25 seconds long, I could be waiting those 25 seconds just for a remote speech engine to process it, because it waits for the pause, it waits for the indicator to go through the final run with a recurrent neural network language model and remodel things, so you have no control over that. So imagine if you're building an application that, as you're talking, you want it to guide you, you definitely want to consider building things in-house. So that's a fourth reason. And the fifth reason is if you want to own your own destiny and build things that have not been done before. So, coming from Tel Aviv, coming from Israel, I listed a bunch of examples, all real companies doing interesting things, analyzing and understanding the meaning of legal contracts, analyzing and understanding how to best order shelf in retail shops, diagnostics through medical imaging, analysis of DNA, anomaly detection, and what Chorus does, which is analyze and understand sales conversations in real time. So I went through 5 reasons to build your AI in-house, and what I'll do in the rest of the discussion is talk about the use case for Chorus AI, bringing on a real live example. Yeah, so I'll go through why we decided to do it. Chorus records, transcribes, and surfaces insights, analyzes conversations in real time. Just a bit of a background. We've been around for 3 years. We're about 50 employees. We're distributed between Tel Aviv and San Francisco, having raised a little over $20 million to date, and we have over 100 customers, paying customers, including world-famous companies, for which we help optimize their sales for. And our offering is called Conversation Cloud. It's built of 3 tenants. We automatically summarize sales conversations that enrich the CRM. So we push, imagine after a conversation, all the data is pushed immediately into Salesforce or a different CRM. We help reps improve their skills by learning from the best sales reps in their organization, and we allow organizations to be aligned by sharing snippets of conversations across the organization. So, why did we choose to build AI in-house? Basically, for all the 5 reasons that I had mentioned earlier: precision, cost, privacy, real time, and the fact that we needed to take our destination, our own fate into our own hands. And more specifically, to fully understand a sales conversation, we developed the AI to do things from end to end. So some of the tasks we did were detecting where the conversation ends and begins, who is speaking at what moment, the speech recognition itself we developed, and various NLP tasks and an affect layer, and I'll go through all of these one by one now. So the first thing is detecting conversation boundaries. So imagine we want to develop a simple feature such as make sure that the rep said X, like good morning, how are you, how is the weather in the first, or this conversation may be recorded in the first 5 minutes of the conversation, or make sure that they set next steps in the last 5 minutes of the conversation. The question is how you actually detect when a conversation begins or ends. So the problem is people are actually chronically late to meetings. So you join a conference call and when did the conversation begin? And no, saying, hi, this is Jack, does not mean the conversation began, because you may just be waiting, he may just be announcing himself. You don't want, and the reason you don't want to just start analyzing for the very first moment, you don't want to be analyzing 15 minutes of silence or of music. It's wasteful and it's uninformative. So, as a solution, we trained a voice activity detection model to distinguish noise and music using a GMM at first and then moving to a deep network. We added additional noise so that we can train and improve over time. And then we built a speaking density model. Basically, we trained a classifier to pinpoint the exact moment where the real conversation started. And again, as I gave the example, hi, it's Jack, anyone here yet, doesn't mean the conversation started. So that's where, that's a very simple task that we began with. The second task is speaker separation. So when analyzing a conversation, even before you transcribe it, you have to understand who's speaking. The reason is it can help with modeling the language, obviously knowing where there's overlap in the conversation, and where utterances begin and end. So this, for 2 people it could be rather simple, but imagine you have 5 speakers, some of them may be in the same physical room, you have people joining Zoom or Skype for business or whatever. There are some in the same physical room and you have to detect who's speaking at what moment. How do we do it? I won't go into all the details, but basically we built a universal background model that enables us to understand most generally how people sound. And the second is we built a classifier to identify reps using 3 types of cues: textual cues, video or visual cues, basically identifying what names are on screen or faces, and voice features, which are the I vectors. So that's for speaker separation. Once we did that, we trained our speech engine. We could use an off-the-shelf ASR like Google Speech, but we'd be losing a whole lot in terms of accuracy. For example, names that are industry and company specific, so Textilvania, Cluj, Zoomtopia, HIPAA, GDPR, all of those things on a standard transcription engine, we'd completely lose, or not get a lot of them. So we trained 3 things. We trained language models that are in domain. We trained acoustic models with the usual standard acoustic surroundings, and a per customer automatic domain adaptation for both of these, or sorry, rather for the language model. And we achieved about 20% better word error rate than cutting-edge industry solutions which are off the shelf. And that number actually even increases when you look at the salient words or at the idiosyncratic words that are very specific to an industry or to a company or to a vertical. So that was critical for us because a lot of the critical information comes from these specific vertical-specific words. On top of that, once you have the transcript, you can begin analyzing what is being said. So what topics were discussed? What pain points were raised? Were there risks in the conversation? Decision-making? What questions were asked? What questions were able to best engage the audience or the prospects? So all of that are things that we built in-house using both semi-supervised learning and completely unsupervised learning, which is quite surprising. We built a novel algorithm to be able to identify topics that we don't know of in advance, which is quite cool. Yeah, so that's another thing that we did with our own AI stack. Another component is prosody and affect, so being able to detect interesting moments. So there's a very big difference if someone says on the call, "Oh, that's cool," or "cool," versus "Oh, cool." It's completely different, and you want to be able to capture those kinds of differences. Another component is beautification. So when text comes out of the speech recognizer, it just looks like all lowercase, no punctuation, and you want to understand what the punctuation looks like, what to capitalize. So you use both prosody, both acoustic signals, and a learned model. We use the sequence-to-sequence model to restore text to its beautiful state. Another component is automatically surfacing differences between top performing and other reps. So what we did is, because we have all the data in Salesforce of who sells better, who doesn't sell good, we could look at this trove of data and surface patterns. And we found some really amazing stuff. For example, top reps use a different vocabulary than lower performing reps. Top reps are more empathetic. They use language that is collaborative. So they will speak in us and we and let's and together, versus lower performing reps that will say things more like, I will send over the contract and you will send it back, rather than we will go over it. So those are things that we automatically surface. And we have a bunch of other really, really cool insights. Some of them are cross-industry and some of them are customer-specific. Okay, I have a minute left, so I think that I'll end there. Thank you very much.
Thank you very much. That was great. And everybody has been very disciplined, so we've managed to recover some time. So we do have a coffee break now, which is sponsored by Bosch. So they also have a booth outside that you can check their technologies. And let's all try to be back at 12:20 so that we can recover some of the sign. Thank you very much.